All right. You just click this thing. Is space bar translate? Space bar? I think that's. Thank you. You should be up here. Okay. We're gonna talk about a few things. Kind of a refinement of the scope of Appendix A. These are all changes that have occurred. We're going to talk about the tension members that are now covered by Appendix. Area in between. That is that wire logs apply to both steel wires and synthetics. So that's embedded in the middle. And so we're going to talk steel wires, some requirements for 9/16 wire and testing of steel wires and cables. We have to harp on wire logs as usual. And then there are synthetic sections in Appendix A. So we'll talk about those as well. Okay, so kind of the focus, the refinement, the fine tuning of the scope that for Appendix A, and that is that I'm not going to read. I'm not going to read all these slides, but I'm going to read this. The purpose of the appendix is to the RVSS is to establish safe and effective operating limits for overboard handling systems, which I've abbreviated OHS, which are used on the academic research fleet. So the introduction of those words, overboard handling systems. The overboard handling systems features a tension member coupling the object and the vessel and paid beneath the water. So systems used to tow objects, lower objects beneath the surface of the water and retrieve objects from beneath the surface of the water. So what tension members are included? Well, right from the get-go, we've always been talking about those tension members that were purchased and distributed by the wire pool. We're clear on that. That's straightforward. Tension members that were acquired maybe independently by the vessel, and you might be those with having an OTH number. We just that's other, not provided by us, but the ship went out and bought it on their own, but they wanted it included in the database, included, and it's given an OTH. The new thing, the new do is the tension members brought on board by any science party or outside organization that are going to be used as part of the overboard handling system. That is the new stuff. So anything that comes on board that's a tension member, it can be used as part of an overboard handling system. They are now included in Appendix A, which means that wire rope, cable brought on board, winch pools, tension members that are loaned from the wire pool, all of those tension members now have to take into consideration the provisions of Appendix A. And what exactly does that mean? Well, we've got to think about the operating requirements, factors of safety, logs. How do you know how this cable or tension member was used in the past? All of the things that you now do for your own vessels have to be applied for anything that comes on board. And again, this is to give the vessel operators something to fall back on so that they can, somebody walks on board with a cable that they have no history about, know nothing about it, no brake tests have been, they can say, well, show me, how is this going to be used? Where's your test data? How has it been used in the past? And if they can't provide that, it gives you something that you can say, okay, listen, we have to do this. This is provision of Appendix A. So we're going to touch on steel wires and cables. Now, one of the things that a change that is incorporated is that on some vessels, the 9/16 wire and the 681 wire or cable. Sometimes I get those iron cables saying, but excuse me. The wire rope, 9/16 wire rope, and the 681 cable are overboarded using the same handling system, overboarded using the same shivs. And a problem that arises is that to use 9/16 wire with a factor of safety below 2.5, but equal to 1.5. So on the hairy end of the 9/16 wire, where you're really pushing it to its limits, there were some very specific requirements, and that was a minimum shift diameter of 26 inches and a groove that was between 0.576 and 0.618. So very close tolerance and very specific. But in reality, the 9/16 wire was being overboarded using the same shifts designed in many cases. And so, which meant that the shift diameter was greater than or equal to 27 inches, and the groove diameter was larger, was 0.698 and 0.748. So it was a bigger groove, more slop between the groove and the wire than what the 9/16 wire called for if you were working down below 2.5. So in that configuration, in that reality configuration, the 9/16 wire was limited to operating safety greater than 2.5. Just couldn't get it down. People wanted to use it. And so in order to do so, it required a waiver. And so we after so many waiver requests, we did some testing at tension member technology, and there was very little degradation in the breaking strength of the wire when it's over shifts that were configured for 6A1. So in order to take into consideration what we found in those testing, the 9/16 wire can be used with a factor of safety below 2.5 and as low as 1.5 if the shivs are grooved between, now you can see the range, 0.576 and as large as 0.748, and as long as the shiv diameter is greater than 27 inches. That is now written into Appendix A. So that's a recent change adopted in June. I wanted to, if you have any questions at any time, please stop and ask Ted, because this is more of a discussion. You know, I want to generate, these questions. We'll try to answer your questions. No, I didn't say we. Ted will try to answer your questions. So let's talk a little bit about testing steel tension members. So the responsibilities for monitoring or determining the tested breaking TBL, tested breaking load. What was it? Load. Thank you. Should remember that. Of tension members. So the responsibility of the vessel operator is that you need to submit a break test request via the ship's wire database, hopefully, the wire pool database. The ship operator's got to send the sample to the wire pool, and hopefully it's been labeled with the NSF identifier and with a copy of the break test request, because we get a lot of cables in. Barbara sitting in the corner there, Barbara gets all these samples in, and we need to make sure that we keep track of whose sample is what. And you may go in one sample, but you've got about 4 or 5 on the shelf that we're trying to keep track of as well. So very important to be labeled, send that break test request in with the sample. And then also a requirement of Appendix A is that you submit a corresponding tension member log, lubrication log. Now these things can be uploaded into the database without, you don't need to send us a copy of it or anything. That stuff can happen all within the wire pool database, and each vessel has a data entry. So the science party, or the outside organization intending to use their own tension member, they've got to provide evidence of break tests consistent with the provisions of Appendix A. And they have to provide that information to the vessel. As a vessel operator, someone coming on board, the science party's got to should be asked to produce that information and provide it to the vessel. Our responsibility, that is the wire pool's responsibility, is that we will conduct the break tests and all the associated tests. We'll provide a copy of the tested breaking load, test those test results. We'll do that. We'll provide that to the vessel operator, primarily through the wire. So you'll get an email, new data or new tension data or test report, and you can log on and get that information. So we do it primarily all through the database. And I did mention you get an email that says there are new results, so you can log in and get it. Yes. Question for Ted.
What if I'm using wire on the ship and I'm down to my last fitting? And I want to send a piece of wire off to be tested.
Well, that's a very,
Because those things are expensive too.
yeah, well, I will get to that, but Appendix A says you should send in a sample for testing with at least one termination that's used in the field. And the reason for that, I think we'll be getting onto that, but the reason for that is that Barbara does all the testing, and we see we don't say huge, we see a difference between the vessels, or the samples that are sent in with a termination versus the testing that we do when we terminate both ends. And it's important, I think it's important, that the operator knows what the quality of their termination is. When we get a full length sample in, and we terminate both ends, we don't know how the vessels are terminating their sample. And as an exaggeration, I'll say, we don't know whether the ship is tying a bowline in the end of that wire and using it that way. Or, they're doing a good termination. So I think it's very useful for you, operator, to know how good your termination is. We've identified problems with NICO press fittings that, they're not crimping properly, and we'll test those. But anyway, the point is that we'll put an end on that sample, and we're fairly confident that we will get the breaking strength of the wire out of that termination, that the termination won't be the weak link. But we want you to know what your termination is. Now, we will also, and that's a requirement of Appendix A. It's actually a relaxation of the requirement, because as it was written, both ends were supposed to be terminated. But we now very backed off, and only one end. But the problem is, it is only one end, but I really think we're going to hold it to it. That's the way it's written. That's the requirement. So,
on that, do we get both numbers then? Because if you termination and one with your termination,
you're going to get one number,
and that'll be the termination rate.
That'll be the termination.
So we don't actually get to know what the wire break is.
If you send me another sample,
Send two samples.
or a very long sample, if you check me on this, Barbara, but if you were to send us a 14-meter sample, we're going to take what we need, and we're going to take your termination, and we're going to put our own on one piece. And if it breaks above the manufacturer's minimum, that's the result you're going to get. But if it breaks low, we will take that other part of that sample and break to make sure your cable, it's not the problem with the cable.
If you're testing the cable, and so for instance, I know with a high degree of certainty that the termination I'm using for our CTDs of the 3 is going to break around 7,000 pounds, and the breaking strength of the cable is more like 11,000 pounds. So if we send you our wire with the termination on one end, then you're going to tell us that the breaking strength of the cable is 7,000.
Yep. That's what's
And
going
that
to
will lower the whole thing?
Yes.
Okay. Because you want the termination to fail first, I would think.
You want it to drop the CPD before the cable fails.
Well,
But in a deep cache, the
That's not really
termination
how
is
it
not going to
works.
say anything.
I
more.
understand. I understand that, and that's why we're willing to do the other piece to make sure that the cable's not fault. Because that's what's going to be at the head shoot when you've got all that cable hanging off it. And the CPD at the bottom.
But it will show you the difference between the different flavors of termination. I think I've put 6 different kinds of terminations on 322 over the years, and they do behave differently.
Barbara has a tremendous showing. Just lost and it didn't make the flight because it was too big, but she does have handouts that show basically how vessel terminated one compare with the manufacturer's minimum breaking strength as well as the results that we've gotten with our terminations, which are, that would be the cable strength. So it's and that's why we're pushing for this getting both, because we want you to know what you're dealing with and maybe correct a problem with your techniques. I mean, we get samples in with you know, on the 322, we use a what is it? Oh, what's what molten material? Yeah, and we go to great lengths to do the perfect determination. And we can, because we, you know, we're in the lab, it's nice and warm.
Master of the bird's nest.
That's the bird right there. That's the bird that's and sandblasted to it. It's great. That's right. And so we can get that to work really well, but we also have seen samples come in because we'll melt the cerebend out of them, and we can see in there. So pretty. We want you to know that it's to help you, really.
Could that be part of, I know that there's some App A, App B training in wood pole in January. Could that be part of it as like a termination?
I bet Barbara would love to do that. Yeah.
Well, definitely.
And we can write stuff too.
Yeah,
Yeah. We did an Inmartech that way.
Yeah.
Not so long ago.
and I have that posted.
Show the.
It'll be in Hawaii by then.
We'll have to come back.
So.
Science party. Are you guys willing to support their,
Say that again?
like, are you guys going to support their break test?
Yes.
Even if it's not like an NSF funded wire?
If it's going on your vessel, we're committed to do a break test. We're gonna do it.
Do you have any estimates?
Oh, we're crying out loud. Some of these questions here.
Just like an estimate on like lead time for, like, if we get a cruise, you guys need a month, 6 months? For the sign.
I'm probably gonna get daggers. Right now, but we do try our damnedest to do it, to get something out in 2 weeks.
And if you have an inspection, something coming up, you're gonna go right, tell him.
Don't tell them.
And bug them every.
So, my last question, for Ryan, I promise.
All right.
Yeah. Is anybody going on an outreach tour to tell scientists that have been going to sea for 20 to 30 years that they're synthetic, that they keep in a bucket somewhere in a container and now needs to be tested?
That's been
Everybody
happening.
that I've talked to.
It's been happening more and more lately.
Well,
Has no idea this is happening.
You've got a document now that tells them, and part of your pre-cruise planning ought to bring that up.
Okay, so. This does apply to anything that's gonna be a part of an OHS, which means a line and a bucket that goes through a capstan, through a block on a frame is now a part of that. And if somebody's got. So that's all true, right? It's going through a capstan or a block or anything through
Is
an
it
A-frame.
deploying an instrument into the water,
In the water.
It goes below the surface of the water.
below the surface of the water?
If it's just to launch something, at the water's edge, it doesn't,
More.
So Blake has to produce.
you're launching it.
That's in the morning.
Yeah.
Well, I'd say. I'd say it should be. My opinion, that is not. I think
It's not, I'm gonna, all right, next.
But really, so the wire pool's not telling anybody, the operators need to tell the science party?
I think that's true, yes.
Okay.
Yeah.
Yeah, we had to get it to our planners to make. Yeah.
All right, steel wires. Let's see, breaking, okay, so a little bit of a change, just to bring everyone up to speed. There was all you or 5, you just have that it expected to see. But now any factor safety that's greater than or equal to 2.5 has to be tested every 2 months. And if it's if the factor safety if you're going to be using a factor safety below 2.5 and down to 1.5, has to be tested annually. I've already kind of touched on this. Submit the brake test request via the wire pool data and the sample with at least one end terminated with the fitting used in the field. I hope everyone understands this, because, and you will not be surprised when we say to you, when your sample arrives, I'm sorry, this needs a termination. With a printout of the corresponding brake test request, sample from. That's the other thing. Don't, so you cut off 100 meters because you're just maintaining your wire. It looks kind of crappy. It's been out on deck a while. Don't send me the old working end that is now 100 meters away from the new working end. The idea is that you send a sample from the new working end. Okay.
But aren't you supposed to use the termination that you had working in the system?
No, you then put on new working end and we will test that.
I can cut it off and send it in.
Right. Do you understand what I'm saying?
I guess I would want to understand the system I was working at is in its weakest state. So for me, I termination that was older.
I want you to know the strength of the cable that you're gonna use the next time it goes in the water. Not what you were doing. That's where I'm coming from. And submit a wire log.
Yeah.
Wire logs. Oh, man. There's another. There's another thing. Wire logs. So according to Appendix A, don't shoot the messenger. Tension member identity. The winch manufacturer, the model number, for example, Pablo SPRE 264. A record of all the spooling operations and cutbacks, including re-terminations. So when you cut back, it should be in the log. When you re-terminate, how much did you cut back? When you know how much you cut back, change the length of the cable. This is the whole idea of the database. Now you can use the database for much of this. You cut back, you can adjust the wire length. That's the beauty of the database. It's kind of a basis for your history, because what we're trying to track here is cradle to grave. New cable, everything it went through, we finally decided to get rid of. A description of the shiv train, number of shivs between the winch and the wire, all the shivs, dimensions, including the diameter, the tread diameter, loop diameter, and the dimensions of the groove. And then for each deployment, the maximum tension during the cast for each deployment, not some summary of how it performed, but for each deployment, max tension during the cast, wire out at the time of max tension, and the maximum wire out for each deployment. So wire out at the time of max tension. That's important. So we can go back and look, know how much wire was out. And now we've already mentioned about wire out. Wire remaining on the drum is a much better. Wire out is good. Wire out is a great parameter. It tells you when the water is too shallow and you get too much wire out. But the wire in is a very valuable expression term as well, because then we know when those events have been cut away, no longer a problem. All right. You clear on that? Very good.
Is that a requirement for science provided wires as well? Mention every log.
Yes, if it's in Appendix A, if it's mentioned in Appendix A, it goes for the science wires that came on board. And that's gonna be your problem, I haven't, I mean, everybody in this room knows they have to submit me a law. But science is gonna, they're not gonna have any guaranteed, and that's why you need to get to them early in the cruise planning process.
So you're gonna tell them that they can't use it, or do we gonna tell them that it's gonna be a 5-to-1 factor of safety, or, you know what I mean, go to your. But it gives you some teeth on the, when this junk shows up and you're like,
I mean,
what is this?
it does not say in Appendix A, you know, you're gonna use a factor of safety of 5.
Yeah,
Because even with a factor of safety of 5,
Still have to
test it.
yeah, there you go.
And I'm trying to remember now, factor of safety greater than 5, wire log requirement.
Right.
Yeah, there is.
Yeah, there is, yeah, exactly, right.
So here's this is just to get the conversation going. Ted and I have been discussing this. We get all kinds of wire logs in. You wouldn't believe what we get in for wire logs. We really want to standardize the wire log. And so these are some of the elements. All of them are mentioned in Appendix A. I just went through them. This is a layout that we thought, or I thought, Ted's got his own version, and it's open for discussion. We're work with you. We want to get something that's going to work for everybody, or most of you, and apply it. But it has all the elements: cruise number, the date, cable length. It's helpful because we have maximum tension, max wire, wire out at max tension. What I refer to as wire in, wire out. And it's just a subtraction between the wire length and the wire that was out, and max wire out. So, and a nice sketch. I must, URI they do a great job with their ship trains. And this is, I grabbed this from one of their wire links. It tells you everything about it, the diameter, the room, you know, it's good. All right. Synthetics. Gonna change gears here.
Going back to the last slide, can you guys provide a template to the community for like wire logs that people can use, like an Excel spreadsheet or?
And we're working on that. Very we're not quite there. And this is where this whole thing about the wire need your help. Because you've got these things that are generating 20 hertz of data. And I don't want 20 hertz of data. I want in a night, like I just showed, if I could go backwards, I would. No, can I go backwards? There we go. You know, in a decent, print it out so we can read it, not chicken scratch. Extract what you're collecting. And I don't know how to do this, but I know you do. Because you guys do it all the time. That data stream, extract the pieces that the wire log needs, put them into if it's X, put it into a sheet like this, and then that becomes your wire log. That's what we need.
Okay, I'm gonna throw Bonnie under the bus.
I'm just like, I've been talking to people. Oh, Bonnie's got that. Bonnie can do that.
I do, we came up with a web-based application that runs on the chip, so it's a combination of local inventory management, you know, maintenance and event logging, and then the winch operator logs events, so you can then just export based on like a date range and what you're looking at. This basically this table in CSV1.
Great.
I know I'm fear people, but I don't want to sort of.
Okay, but that would be great if you know, could show people.
Yeah, I'd have to learn a few things to make it work, but definitely.
I know you can do it.
And then we can share it.
Good.
Our problem's obvious in that we're sending stuff out with different user groups every single time. and they're using them in different configurations. We're not there to see how they're actually using them. It might tell you one way and then change things midstream. Who? I know the answer, but it's not a good vision, taking care of this wire lock. In Woods Hole,
Well, you're collecting the data.
we're collecting data as far as the tension and metering. Okay, now what? What about the shifts? What about the placement? What, like the guy that goes on the Langsat and runs a $9,000 parking block on the deck as a running block and strings it up to the A-frame and then blows out the wire and almost
Lights
loses
it
his
dry.
instrument. Yeah,
No, no.
we have no control over it, and we have no control as to whether or not they actually do this. All we have is what's in the electronics that's been logged out and provides to you, tell you tension, we can tell you cast. We can all basically tell you, they do Toyos exactly if that was a cast or not, unless they provide us with that information.
Well, given that this is a requirement, how do you think we should work on it?
Honestly, right now, I don't know. I don't want to say, well, the tech. They're borrowing wire from you. I'm borrowing wire
They're
from you.
borrowing it from me.
Yeah.
And I hold you
For them,
responsible.
for them,
For
at their
them.
request.
But you're my man.
Yeah.
You're getting the data.
So, and then throw it to make it even worse. It's not your wires, it's gonna be the ones they bring on their own, where they've got no logs, and they're not gonna provide a log.
That's not your problem.
It's not my problem. Well, I can
Or
tell them
are they-
basically I'm not putting it on the winch and good luck.
Then it is your problem.
Yeah, I could bang on a pissed off.
So I've got one thing, if, in my recent experience with having a winch from a winch pool with cable that came from someplace. Just a team failure in the ability to have discussion months in advance about the data coming off of that winch. And who was responsible for it, or how that was all gonna get shared and figured out. I think I failed to anticipate all of the things, but if we have a deeper discussion, before a winch goes anywhere onto a ship, you know, how do you plug into it? Just to talk to it, and then what kind of format is gonna come out of there? And how can I integrate that with my own logging system, or do I borrow something? Do I take another bit of software from you guys, right? Like, to have that conversation ahead of time so that you can do this, you know. It's not hard for me to make that out of my own data on a ship, right? But if we have the conversation far enough in advance, I don't think there's any reason the existing ships, technicians, can't get the data that satisfies this chart. Just so long as raw numbers are there. And times put into integrated into the existing logging system.
But the tech isn't responsible for someone provided. Why?
Sure.
So like, in my mind, in the pre-planning process, to establish that there is going to be this, you know, worst case scenario. Doesn't know what they're talking, doesn't know what they're talking about. They've never heard this before. You present it to them, they say, where can I find support? And then we send them to you.
We'll break it. Log for them.
Yeah, but at least like in terms of professional support to clarify what they need. You can provide them some more.
And you can show them, you can show them the doc. You have to, I am obligated to follow this appendix. That's your fallback. I know it's hard.
But you guys broke that Vectran, right? So there's some Vectran running around, you know, fleet that's 322. That's great. You can just spill your 322 off and I'll use that to put my pumps over the side. When it comes back, it's like, hey, the same Vectran you brought 6 years ago? Oh, yeah, it's the same one. When we talk to the guys at Scripps saying, hey, this is coming your way next. Then talk to the manufacturer, like, flies somewhere around the 2,800 meter mark. And it's like, crap. And so before it went onto the woman's or onto your bill, right? Like, we're like, well, break this for us first, because we don't know what's going on with it. We had no history on it, just shows up, we have no idea how it's being stored.
Oh, yeah. And if it's jacketed, you don't know what's going on inside.
Exactly.
All right, let's see, synthetics. All right, so the starting point is factor safety of 5 or greater. D over D of equal to 40 is required per the provisions of now table or 8.813. So if you have a synthetic, you're overboarding a synthetic, right from get-go, it's going to be a factor of safety of 5. Now, for many applications, that's just not going to be good enough. And one casing point is that the Armstrong wanted to do coring in the Puerto Rico Trench, and they wanted something, they needed to get down to 8,000 meters. Wire rope by itself wasn't going to hack it, it would break before it got. And so they wanted to use synthetics, but they couldn't use, this is 9/16 plasma, they couldn't use it with a factor of safety of 5. So what we did was we went to the manufacturer, got all the specifics, which is this here, all the specifics about the overboard handling system, the shivs, anticipated loads, numbers of operations, and were able, over a considerable amount of time, got it to the point where it looks like if we allow a lower factor of safety, they're going to be able to do their work, and the rope's going to last. But that takes time, and that's the point. It takes a lot of time and to get that kind of information. Now, will it always be this way? I hope not. We know nothing about synthetics, and we're looking, but this is the way we're going to start to learn, is by able to work with the manufacturers and determine if we can get down safely, given the past history of the rope and the planned operations that are forthcoming, whether we can safely use that rope to do the operations that are planned.
And guys, I want to just here, having been on this cruise and I've used a fair amount of synthetic right now, I personally think this stuff is slightly terrifying. And this factor of 5 safety, or 5.0 factor of safety, if you have science party that is coming on your ship and they're like, oh, I've got this new, whatever, 1/2-inch AM steel blue, and it's the greatest 30,000-pound breaking strength. If you look at Cortland's, and Cortland, in my opinion, right now, as far as American manufacturer, is probably the best, the most manufacturer. I'm not like a Cortland, paint side thing, but it seems like in my experience and the testing we've done and the stuff we've used, they seem to have the best numbers. If you look at their fine print on their specifications, they say if you're anticipating shock loading and that kind of things, it can be up to like 25-to-1 factor of safety. So their fine print is, this stuff is actually not that strong, and it's their age 2 of like specific on like the ICO. So the stuff it does break, and it's not, when you're breaking, you kind of know you're breaking. When you're breaking it, I broke a piece last week, and it was 1/2 inch, and I broke it at like, lifting something was like 3 up. I was running a piece of rope over a forklift blade, of course, but like it didn't.
You did deal
Doing great.
Yes. But I mean, this all the time, case in point. So it is like this factor of 5 for this stuff is, I think, incredibly important.
It's also just a different animal, right?
Oh,
And it takes
totally.
different care and feeding. Yeah.
Discovered if you tie a bull and its chances of 25-to-1 lower than if you were to do a splice.
Okay, so what do we need to be able to work below a factor of safety? Comprehensive log for all previous deployments And this is why we've got to get into the practice of having this logged information. Because if we don't have it, if you skip something, oh, I forgot to include this little entry here, we overloaded it for 700-800 cores or whatever. That, we've got to have a good log. Tread diameter, groove diameter of shivs, science requirements. We mentioned the dry and wet weights of the gear, the weight of the samples that are going to be collected, and any dynamic load or static loads such as pullout. We need to have an estimate of those things. We're going to go work with the manufacturer and try to determine if that particular rope or the rope that you have on board operation. Okay, so we have to test synthetic, or how best to test it. And now this can be kind of confusing, so I'll try, if you have any questions or if I'm not clear, I'll try to make sure it's clear. But the samples requested before and after. Now, this is different, before and after each cruise when the synthetic is utilized. So we need a sample before and a sample after. And the sample before can basically be the working end, what you have. Because you will have already tested the sample after the cruise. So at the conclusion of its use, now you've just used it, the cruise is over. So at the conclusion of the cruise, sample from the extreme working end, what you're used to pretty much sending for wire rope, is not representative of the rope's condition. So we need a sample that's gone over around all the ships while under load. The sample location and length will vary from ship to ship, but the hope is that provide post and contributes to the determining to what degree the use of the rope has been affected. So I think it's that the sample before the cruise is at the working end, the end of the rope that's sitting there looking you in the face, but the sample post cruise could be further in. So the no sample right near the load, because it's going around all these shifts, going all traction heads, going around, and then finally gets to the winch drum. That's right where it enters. The winch drum is where you want to take that sample. Yes, that can be 100, 200 feet of rope, but there's no sense in testing the rope unless you're testing a piece that's gone around all those shifts. Because going around all those shifts under load is what is going to deteriorate that rope. And that's where we need to get the sample to see what the deterioration has been.
In that example though, isn't the cable behind the traction head not under tension, but it's still being bent over shifts?
Historically, it would have gone over the ships during the operation.
Sure.
Through the
Sure.
traction.
Yeah.
So that's where we would want to be post cruise sample.
That's during serious controls, has been going back and forth.
Yes,
You're talking 20 meters,
the way it's written.
cutting off the end of a cable.
I'm sorry.
Yeah.
Mhm.
Yeah, if that's 681, we're doing it once a year.
No.
This is
Synthetic.
Right, it's
You can burn it through a lot of cable.
yes,
Right.
but it's not going to be this way forever.
It'd be gone in a year.
Yeah, no, it's, you got to test the rope. The worst case, where the rope has gone over all of those ships. I knew you weren't gonna like that.
Livestock in Portland.
Yeah.
Yeah, right.
All right, so another part of the appendix talks about evaluation of the tension mount. And in this case, not just the brake testing, which we just covered, but a visual inspection. So things such as surface abrasion, new rope can be put into service, kind of fuzzy. That's normal. The picture on the right actually shows abrasion that that resulted in roughly 10% strength loss. So abrasion is a surface abrasion is a, and one of those visual inspection things you want to go over. And you can do this when the rope's coming back from a deployment. Internal abrasion, in this case, it's pretty minor. You can see the surface abrasion, but because stuff can get inside the rope, there can be sandblast grit, you know, who knows, rust can get in there, and all that stuff as the rope is flexing is going to be deteriorating. So rope is from the ins, yeah. Well, yeah. I don't think that's a problem, but we once thought that was. Cuts.
I was gonna say, when on the Armstrong Thompson also, we always during transit, keep it up off the deck, and it's gonna be if an edge of the block was coming into contact with it when it was loose, we, you know, make it so it wouldn't shake.
Yeah.
And Rick, I'm curious, maybe it's coming up on the Thompson when we use this on the Dynacon wedge. That melted.
Yep.
Yeah.
Yeah.
Are you gonna talk about that?
Yeah, good. I don't have a picture of it, but I'm just gonna mention that.
Okay.
So, obviously cut strands, issue that's gonna weaken the
That's
rope.
exactly what my forklift brake looked like.
It's time to get rid of that little piece right there and then. Pulled loops, usually you can work the pulled strand back in, if you milk it back over the rope, you can get that to sit better. But you don't want to be using the rope with that because it's not distributing the load amongst all the strands. Burns is what Chris was referring to. You might have heat burns. We had on the case of the Dynacon winch, it was slipping on the slipping.
Yeah.
And rather than stop and try to take advantage of the static coefficient of friction, the winch was continuing to run, and it had a lower coefficient of friction because of the dynamic coefficient of friction was less. And we ended up with actually heating up the rope and taking off some of it's plasma hyco for high coefficient. It has a high coefficient of friction coating on it, and that was actually coming off.
It's like a snake skin on the on the
It's bad.
or it should be.
I have a jar. But
We dropped a 6,000 pound load doing that once. Because they were slipping it on a capstan head. And the friction caused the line to melt. And then when we stopped the capstan, the heat from the friction got sucked back into the capstan head, and all the fish scales turned basically to glass, and this thing just went spinning out. There's no way to stop it. Oh, wow. And then just happened to draw a hockle, and the whole locked after we dropped about 15 feet, and the whole ship shut like we hit something. And everybody's holding tag lines to releases and trying to let the release go, and away it went, but it could have been really, really bad. It was just synthetic line, and we were slipping on ahead.
Yeah. Uneven diameters. I've seen the one on the bottom more so than the one on the top. I think they just. Well, that one was, the one on the bottom, you're actually, this is a double braid, so whatever's going on inside of that second inner layer must have been compromised in some ways. These are all just things for your visual inspection. Contaminants. So we mentioned abrasives that might get in. Sandblast grit if the tension member is on the ship and some work's being done, or rust getting into the fibers. Exposure to chemicals, washes that might be used on deck. You gotta be careful about splashes, and discoloration as a result of some chemical exposure. That's not good either. UV, here's two ropes about the same. They are the same. Originally, they started out the same. One's been used on deck and exposed to UV. The other one is moved, so you can see the difference. Nice to be able to compare. It's kind of rather amazing when you see the two side by side. Three things we talked about. You know, look at the splice, obviously, make sure the tails are there, they didn't get sucked in. Is the thimble not cocked? You know, we've seen stuff come back with the thimbles at right angles to oriented. The condition of the thimble, I've spoken in the past about thimbles that collapse because they're too thin, not heavy duty. I mentioned the splice, the tails. So you want to look at the splice particularly, because that's where you're probably going to get a break because of the stress concentration during the splice.
I'm just saying avoid the standard duty.
I'm done.
Okay.
So. I think that's it. I'm sorry. Any other questions? Oh, sorry, Ted,
That's okay. It should be on should be on the web anyway.
okay.
Like there's more conversations had, but yeah, maybe we have to continue this online or, you know, instead of doing some more pointed conversation. You know what I mean? Like a Zoom or something session where
You said you have a workshop coming out, yeah.
Yeah, January.
Appendix A.
Appendix A, Appendix B, January, I think it's 18th,
17th is
17th, 18th.
I'll mention that at the plenary.
At Woods Hole.
Okay, that would be great. Is that what's whole?
Yes.
See, January termination. Dates are okay.
Great.
I think.
Very good. Thank you.